On AV2-5, we're going to calculate the volume of pyramids. So here's a bunch of jokes about pyramids. This one's my favorite. Good. Okay, if I took a pyramid and a prism that had the exact same area of the base and had the exact same perpendicular height, I could take that pyramid and I could fill it up and dump it into that prism, and it would take exactly 3 tries to do this. And there's a video of a stranger on the internet doing this. I mean, if you were in class, you watched me do this as well. And so what this shows me is that it takes 3 pyramids to fill a prism with the same base and height, which means if I want to go this way, a third of my prism could fill a pyramid with the same base and height. So I'm going to use the formula 1/3 B, which is area of the base, times H, which is height of pyramid. Okay, and that'll give me the volume of any pyramid ever. So for example, I've got a pyramid where the base is 10 by 8 and the height is 7. So I'm starting with my formula 1/3 area of the base times height of the pyramid. And I'll get 1/3 times area of the base is 10 by 8 and my height is 7. And then it's just plug and play. So I'm doing 10 times 8 times 7, divide all that by 3, and I get 186 2/3 inches cubed. On this second example, my base is a triangle. So I'm looking within that base to find the perpendicular measures. Those will be the little b, little h, base and height when I'm finding the area of the base. I'm still going to do, though, 1/3 area of the base times the height. I just have to think back to AV1 and remember that, hey, the area of that base is a triangle. 1/3 times a half will be 1/6. The base and height of that triangle worked out to be 6 and 17.5. And then my height is 10. Again, this is just plug and play. 1/6 times 6 is 1, times 17.5 is still 17.5, times 10, I get 175 meters cubed. This time my base is a hexagon. I'm still doing 1/3 times area of the base times the height. The only tricky thing is I have to think back to AV1 and say, okay, the area of that base is half the apothem times the side times the number of sides. And I'm going to plug in everything I know. 1/3 times the half will work out to be 1/6. My apothem is 2. Each side is 3. I have 6 sides, and my height is 4. 1/6 times 2 times 3 times 6 times 4. When I throw all that into my calculator, I get 24 centimeters cubed. This time we're going to work backwards. Okay, we know the volume. We're given the height, so I'm going to use those 2 things to find the area of the base. So I'm starting with 1/3 area of the base times the height equals my volume, and I'm plugging in what I already know. I don't know my base, but I do know my height, and I do know my volume. 1/3 of 6 is 2. When I divide by 2, I get that the area of my base was 52.5 square feet. I'm going to take that area and plug it in, knowing that the area of a pentagon is half the apothem times the side times the number of sides. Plug in everything that I know. I don't know the apothem. I know each side is 4.2. I know I've got 5 sides, and I know that area has to work out to be 52.5. A half times 4.2 times times 5, sorry, works out to 10.5 times my apothem has to equal 52.5. And when I divide both sides by 10.5, I get that my apothem is exactly 5 feet. When I'm asked to find the volume of the composite figure, I want both parts. Okay, so I'm going to add my pyramid to my prism. My pyramid will be 1/3 area of the base times the height. My prism will just be base times height. 1/3 times area of the base. The base will be a square that's 12 by 12. And the height of my pyramid is 18. So just the pyramid part is 1/3 times 144 times 18, 864. My prism then still has a base of 12 times 12 times a height of 15. 144 times 15 will be 2,160, and I'm adding those two parts up. So when I add the 864 for my pyramid, I get 3,024 meters cubed. This time I'm going to use algebra with it. I'm still doing 1/3 of my base times my height. My base is a square where each side measures 5a. So I'll have 5a times 5a, and my height is marked perpendicular way in this corner. I'm using 8a. 5a times 5a will be 25a squared. (25) times 8 is 200. A squared times a is a cubed. All over 3 works out to be about 66.7 a cubed. We'll do one more using algebra, and this one's tricky because my base is this triangle. My base and height always have to meet at a 90-degree angle, so I should have 7x and whatever this side is. But I'm not given this side, so I'm going to use the Pythagorean formula. I know that 25x squared has to equal 7x squared plus my missing side, which I'm going to call b squared. And then I'm just working this out using the Pythagorean formula. So 25 times 25 is 625. X squared has to equal 49x squared, 7x times 7x, plus our missing number b squared. 625 minus 49, I'm at 576 x squared. And when I take the square root of 576 x squared, I get 24x. So I'm using 24x as the base for the area of the triangle. So I'll do 1/3 area of the base times the height. My base, though, is a triangle, so I'm doing half little b base times little h height. So I'll do 1/3 times a half times my base and height are 24x and 7x. And my height is 30x. And now as I solve this, I'm going to clear my fractions a bit. So I'm going to say 24x divided by 2 will be 12x. And 30x divided by 3 will just be 10x. And this is way easier to multiply now. So 12 times 7 times 10 works out to be exactly 840. X times x times x is x cubed.